TTL Computer 2. Today we'll be taking a brief look at our completed hardware build out of TTL Computer 2, and then we'll get right into testing our first full duplex test of our serial card, and then we'll be looking at executing our monitor for the first time on our completed hardware, and we'll look at testing some of its features as well. So we're going to get right into this. So we're just briefly looking at our completed build out. You can see that we have our power connections are completed on our enclosure. We have our serial. Our serial connection is completed on our enclosure, connecting to the serial card. And then we have our little green reset button, our external reset button for the computer, and that's all good to go as well. So we're all powered up and have our serial connected to my laptop terminal, and we're all ready to go. And we're going to give that a try now. And I am going to press our reset button, and we'll hopefully see this spring to life on my laptop terminal. And yes, there we go. We have our full duplex serial communications going to our serial card, and our computer is officially springing to life. And we can see that we come up and the serial is initialized at 38400 baud with 8 none and 1, and our terminal looks to be going. So we see our question mark for our commands, and you can see that I've added a new command, which is for setting the baud, but we're not going to mess with that today. But hey, that's it. Our monitor looks pretty good. Let's just do some basic operations. We can do a dump at address 0, and there we go. We can see the start of our ROM code with the title for TTL Computer 2, and then going on. And yeah, the system is pretty responsive. So that's looking really good. Okay, let's take a look at, let's end that. Okay, how about we can try to modify some RAM, address 9000, and this just has garbage in it. And however, the RAM powers up. Let's try the go command, and we can jump to address 0. And that just goes back to the beginning of the monitor and reinitializes the computer with the jump statement there. And then how about we can do, let's try this. We'll edit memory here, and I believe 39 is the opcode for jump. And then we'll just put 0, so we'll jump. All right, so that should be a jump command back to address 0. That should be the same as doing go 0. So let's try that though. So let's go to address 9000. There you go. And that was just a jump back to, again, the beginning of initializing the computer. So that looks all really good. All right, so we've done the dump, we've done the go to, and we've done modify. That's all good. All right, so let's try our first Intel hex load. And we're going to do that by pressing I. All right, so that's ready to go. Now we will do a file send, and we're going to look at how about, here we go. This is our thread test program, and that's going and being transferred up by a serial, and that's completed and good. So we know that loads at address 8000, so we can do just a dump on 8000. We can just, in fact, see the code that's there that got loaded. We can see the message here, thread queued. So we'll see that in a minute. But all right, so let's do go 8000. Okay, and we're going to do that now. Thread queued, and we can see now that thread is in fact running. Okay, so that thread is going and running in the background, and we can take a look, and let's do the dump command now. We can see that this is running virtually just as fast as it was before. So we're having good system response with the additional thread going. Now let's do this. We're going to do go 8000 again. Now that says thread 2. So we have two threads going now, and they're both doing the same thing. They're both updating the hex display. Let's do our dump command again. So we can see it slowed down maybe a little bit with those two threads going, those two things running in the background. Okay, and then what we can do is to end those things, we can just do go 0, and I'll just go back and reinitialize the system, and that will end those threads running in the background. Okay, let's take a look. So we looked at that thread test program. We'll just take another look at another little simple test program I put together. And that is transferring over to the computer. Okay, and let's do go 8000. Okay, so this is just a simple little string test program. It's really just testing uh, the the string reading procedure that I built to gather strings from the terminal. So we can see we can just put whatever we put in will go as the string, and it'll tell us what the length of the string is. Now the string function the string function will return when you hit enter. Will accept the string. It will also return after a given number of characters. And I've set this up to be return after with a maximum of 8 characters. So 1, 2, 3, 4, 5, 6, 7, 8, right? And it automatically returns there. And then the get string function also implements backspace. And I saw that this doesn't work exactly right. It is backspacing, but it's not erasing the other characters. So it did take that right, A123, but I'll have to look at that in the terminal. It's not erasing the characters as we backspace. And then we just do X to exit that function. Okay, so this is a successful test. I mean, this is pretty much validated all of our uh, initial build for our computer, so that the serial I/O seems to be working fine, and we're getting uh, no execution errors, and our system seems to be running really stably, which is amazing. And we can also do our hex loaders working, which is just that's awesome as well. So we can really, now that we have the hex load being able to go, that that will really cut down the need to have to do burning in ROM updates into our EPROMs. So that's good. Now, so I'd like to tell you that this all worked the very first time. It did not. So I had some serious problems when I first booted up. When I first booted this up with my first attempt to execute the monitor, and what I was seeing was really, really odd. So I was seeing, let me say, I'm gonna do. So when it booted up, I would see just like parts, only parts of the strings, and then gibberish. So I think I did the question mark, and I would see, up to here and then maybe up to here, and then it would be gibberish. And I didn't know what was going on. And but the computer seemed to be operational, but everything that I was seeing on the screen was all severely truncated. And then even when I did a dump, the hex display was going, but characters were being chopped off. Not all the characters were displaying, but I could see that the dump function was running, but even all the values in the data was all wrong. It wasn't anything like you can see here. You can see the text that's embedded in the ROM, and I was not seeing any of that. It was just complete gibberish. So I really didn't know what was going on. I kind of figured out, kind of in short order, that I was seeing that the stuff was being truncated. Um, I noticed I was getting, parts of strings, and then it was garbage. And I figured out that I knew that the serial card has has FIFO buffers and receive and send buffers, and those buffers are 15 characters. So from what I was seeing, I determined that the computer was sending characters too quickly to the serial card to be sent. So it was filling up the buffer, it was filling up the send buffer, and then garbage was going. So like the first 10 characters would go, and then it would be garbage. So I knew that I had a programming error that I needed to make to check that the send buffer is not full. So that I did, and I was pretty confident that was the issue there. But on the other stuff with the memory, I was really concerned that we had some serious memory issues in the computer because all the data I was seeing here was completely wrong. And I would even do the modify command, and I would change the values. I change the values and put them in, and then do the display again, and it would just be gibberish. The values would be gone. So I was really concerned that there was some weird um, hardware problems going on in the computer, and I really spent a whole day being really going over the code, trying to just and not a really good frame of mind, and disappointed with the apparent serious errors that we were seeing. But I knew that we had the serial uh, sending problem, so I wanted to get that done and fixed first. And so I got that completed. I think I noticed I had one small error in one of my macros that I was using, and I made that change. And then so I tested that all out in the simulator and uploaded it to the computer. And lo and behold, after that, that fixed all of the issues between you know, changing the send code to make sure that the send buffer wasn't full, and that little macro fix that I did cleared up all the problems I was seeing. And the computer's been running really solidly since then. Haven't seen a single glitch. So I'm really feeling good about the computer build now, and that we have a really good stable platform. And what I even did was I went back and I resurrected that memory check program that I had, and I had that spin through all of the RAM from 8,000 to FFFF, and do modify the RAM and then reread it again. And that ran through fine without a single error. So I am pretty confident at this point that we have a good and stable computer, and it's running at 4 megahertz. And I am pretty confident that we could pop out the 4 megahertz crystal and put in the 6 megahertz crystal. And I already have that crystal, so I'm going to do that at some point and see if we can't get that extra bit of speed out of the computer. But yeah, it's looking really good. And again, pulled back from the abyss that one day after doing the first full monitor run, was really not in a good way, and disappointed. But fixed those issues, and it just looks great. It just looks great at this point. So our next video, we're kind of going to do a little bit of a review on what we've achieved, and then we'll talk about what's our next steps with TTL Computer 2. So until next time, that's it. Thanks for watching.